Hello there! Alright, I'm going to talk to you a little bit more about Chapter 7. We're going to talk about something called correlation. And correlation is a word that's thrown around a lot, and it's often misused. Correlation is actually a calculation you can make to measure numerically the strength between two quantitative variables. So you have two quantitative variables. And last video we looked at scatter plots, and we wanted to see if they were, we wanted to describe them, and we talked about basically, four things. We talked about direction, strength, form, and anything strange. So let's just a quick review of that. If I was going to compare these two, I'd talk about the directions first, and I noticed that they're both negative, they're both heading down. Then I was going to talk about their strengths. I'd say, well, this guy looks a little stronger than this, because, we said strength is when they're closer to the, they're all closer kind of together and not as much scattered about. Form is just whether it's curved or straight. This guy looks straight. This guy looks a little curved, and I don't see anything strange in either one. And when I say strange, I mean like real gaps or outliers. So, if I was going to look at these two down here, I do see something kind of strange happening down here. I see a gap and a gap, and I think I see two outliers. But outliers are a little bit different when we're talking about scatter plots and things like that, because an outlier isn't quite what it used to be. An outlier, we look at it a little bit different now, and here's how I look at an outlier. It's called the pinky trick. I see a dot, I say that might be an outlier, and I'm not 100% sure if it's an outlier. I'm getting a little transparency here, so just hold on. There we go, that might be better. You can see the other papers underneath there. Okay, so I'm looking at this point, I'm saying, is that an outlier? Well, it seems that, this might be a positive association happening here, but let me take my little pinky and do my pinky trick. Ready? Cover it up. Now that it's covered, I'm going to look. Do you see some sort of relationship here? Now this relationship looks like it might be negative. And now I pull my pinky off, and I notice, oh, wait a minute. This guy doesn't go with the rest of the points. So these guys tend to be going negative, and this guy's like out there. So when you cover it up and say, all right, I look for the trend there, and then uncover it, it seems like it might change the trend or doesn't quite go with the rest of the points, we can call that an outlier. So obviously when you're looking at this guy, if I know right now you're probably doing the pinky trick on your computer, you're going, and you notice when I cover this guy up, you see there is a trend. And then I uncover my pinky and I say, oh my God, it's following the trend. So if I added a line to this trend, this guy would be way off it, and this guy would be right on it, so I wouldn't quite consider that an outlier. The problem with this guy, actually, he's way out here, he's highly influential. He'd actually end up making instead of seeing the actual trend that's really happened, this guy would suck the line up and go and change the whole look of the line and make us think it wasn't really as negative as before. We'll get to that later on. Don't worry about it. Anyway, so let's focus on two things. Major things here we can measure: direction and strength. And that's what we're going to talk about. And when we talk about direction and strength, we're going to focus on the R value. Yes, it's called the correlation coefficient, and don't let the little lowercase r fool you. It is the king. Notice it's been crowned, and it measures strength. And you'll notice if you go to a gym or the Gold's Gym, you see the muscle heads. They're like, yo, check it out. I just got a new tattoo. And that's like their R value. They want to show that they're strong. So they'll be like, R.998. Look at my tattoo. That tells you that I'm very strong. And if they're happy, maybe they'd stay positive. And suppose they're like strong, but unhappy people, they might do that. I'm still strong, but I'm strong in a negative way. And we'll get to explaining what that means. All right, so let's go and talk about some basic R values so we can think about them. R values range from -1, the strongest negative relationship, to +1. So let's look at a -1 relationship. It would be a straight line, right lined up. This guy is also, fairly strong, moderately strong, I'd say. He's also negative, but it's not as obvious. It's not all lined up perfectly like an R value of -1, so it's -0.7. Here's an R value of 0. It's pretty weak. It's like so weak that there's really nothing happening. It's neither positive nor negative. And then I have a value of positive 0.7. You can see that there's definitely something positive happening here. Something that you can feel good about. And right here I have a perfectly linear, straight +1. So notice that the further it gets away from 0, the stronger. It's stronger out to the extremes, closest to +1 and -1, a real strong relationships or associations or correlations, and it's weak as we get into the middle, okay? It's weaker in that direction. So you're wondering, how do we calculate it? Well, same way we calculate everything else in this class. We use the TI, of course. Why would we do anything by hand when we have a calculator? But I'm going to show you quickly exactly what the calculator is actually doing. Real basic. I'm going to show you real quick. Suppose all these points, imagine all these points, they all have x values and y values, right? So they all, have certain x's that go here and certain y's. Imagine if all these points went and just fell, right? They'd all fall right here and they'd all stack up and we'd end up having like a little histogram here of all the x values. And the histogram would look something like this, I don't know. Well, that histogram has a mean of all the x values, and we call it x bar. Well, that x bar is a very important point. It's the middle of all the x values. Actually, looking at this guy would be a little bit over more, but whatever, I'll put it right here. X bar. And now suppose these guys all got sucked this way. Shoop! Well, they'd come all the way over here. Suppose there's a magnet that sucked the points. You'd see over here, there'd be another little dot plot looking at all these guys would be stuck. There'd be a little histogram, and there'd be a middle of all the y values, and that guy would be called y bar. So that bar just means mean. So this is the mean of all the x's, the mean of all the y's. Well, if I go straight up from x bar and straight over from y bar, I get a very important coordinate, which is the coordinate, you'll never guess it. Wait, yep, I said it. X bar, y bar. It's right in the middle of the whole scatter. And what this does is it splits all the data values up into 4 quadrants. Remember, 1, 2, 3, 4. And all of the points that are in here, in this area, in this quadrant 1, add positive values to the R. Everything in quadrant 2 adds negative values. Everything in quadrant 3 also adds positive values, and everything in quadrant 4 adds negative values. So these guys add negatives. Obviously, you see a negative scatter. Of course, these guys are going to make it more negative, and these guys are going to make it more positive. Okay? And you can see here we saw a positive association. It's kind of straight, pretty strong, and you can see that all of these guys are adding positive, and there's only like 1, 2, 3, 4, 5 little points that are going to add little negative values, and all of these positives. So these negatives might cancel out a couple of the positive values, but look how much positives left over. So obviously the net the net sum is going to be positive at the end because there's more positives. The positives outweigh the negatives, and that's pretty much what it does. It finds the sum of all these little squared distances, sort of thing. All right, and we'll talk about what I mean by that. Anyway. So it's a good little tool you can use because sometimes you look at an association you're like, I'm not sure if that's positive or negative. Well, what you can do is just say, all right, let me see. Well, the middle of the x's are like right about here. The middle of the y's are somewhere right around here. Let me just do a little thing here and say, where are most of the points? Well, there's a couple here, a couple here. It seems like, well, I got a few more points here and a few more points here. So overall, this is, I'd say, a little bit negative because it's adding negatives. All right, whatever. There we go. So let's move on. That's how it kind of does it. It's a little more technical, and we'll do that in the next video. So we are now going to use our TI. Dun, 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 to the rescue, to the rescue. I got my TI to the rescue. How do I calculate it on the TI? We're going to talk about it. So we're going to look for an association between the number of texts you make during my class during a week, and see if it's associated with your hardest quiz in the world on Friday. So what I do is I have a list here. It's the number of texts and the quiz grade that you received. And I want you to pause right now, if you're going to do this along with me. Pause your video and enter this into L1 and L2. So L1 and L2. No, actually, I entered it in L3 and L4, so I take that back. Put it in L3 and L4 if you want to do this with me. And this will be my X and my Y. Generally, if the first list is going to be your X and your Y. So I'm going to see if my texts can predict my quiz grade. Okay? And you can pause right now, and I'm just going to show you what I did on my TI. All right. Let me see. Let me just unhook this from the tripod. All right. We're going to take a look at... All right. So I got my handy dandy calculator here. Whoa, look at that. Pretty cool. Let me turn it on, and I put it in L1 and L2, and L3 and L4, as you did. There's my data values. And now what I want to do quickly is take a quick look at the scatter plot. So, remember we said we hit yellow. The yellow to turn on the stat plot. My stat plot, it's on. And notice, I've got a couple things on. Plot 1 and 2 are on. Plot 1's making L1, L2 scatter plot of L1, L2, and plot 2 is doing a box and whisker plot of L2. I don't want any of this stuff. So what I'm going to do quickly is I'm going to go in to plot 1. I'm going to keep it on because what I want to do is I do want to do a scatter plot, but I want to do L3, L4. So I'm just going to go down, and instead of L1, I'm going to hit second, 3, because that makes it L3. And then I'm going to do second 4. Now I'm going to L4. And that's what I want. But I know plot 2 is also on. So see how there's plot 1, 2, and 3 up top? I'm just going to go right up to plot 2. Make sure that's off. Because I bet you if I graph right now, there's going to be, look at, there's like a weird scatter and a box and whisker. I don't want any of that. So I'm going to go into plot 2 and shut that off because I only want one plot on. See how it's on? I'm going to shut this guy off. All right. You. Off with you. All right. So now I'm just going to graph. It doesn't look very good. I wish I could zoom. Oh, remember I can zoom in on this better. So it's called zoom stat, which is zoom and then the button 9. And ooh, look at that. I definitely see something negative happening. So now I have an idea that it's kind of fairly straight. It looks kind of strong. There's not too much scatter. If I draw a line through here, they're all pretty close. I mean, I don't have a lot of data values here. But let's see if we can calculate the R value. So to calculate the R value, we're going to do some calculations, some statistical calculations. So you're going to go right where it says stat. You're going to go over to calc. And what we're doing is called a regression, a linear regression. And right here is lin reg. So not only is this going to calculate the R value, it's going to give you an equation for the line of best fit in the form y equals mx plus b. So there's a line that goes kind of close to all those points, and it's going to give it to you. And we're going to show you how to plot that in another video. But let's just go to 4, which is lin reg 4, and I'm going to run lin reg, and I need to tell I want to run a regression on list 3 and list 4. So I'm going to type in L3, comma L4. And it's going to run the lin reg. So now I have my equation, y equals ax plus b, right there. So it's obviously going to be y equals my slope is negative 1.3 x, and my intercept is 96. Okay, but what's my R value there? Look at that, negative 0.9. R equals negative 0.9. That means it's pretty strong. Wowzers. And I'm going to talk about what this equation means. I wrote it down right here in a little bit. So remember, that's how you find the R value. The equation, I wrote it right here, is telling you that, just real quickly, that y equals 1.3 plus 96. Well, y is simply the quiz grade. So it's what it's saying is that your quiz equals negative 1.3 times texts plus 96. So what that means is your quiz grade, if you had 0 texts, and I plugged it in, you'd end up with a 96. But for every text message, you go down 1.3 points. So stop texting, people. All right, anyway, is that true data? Yes, that's actual true data. I got that from the Department of Education. It's really what happened. They did this study, this really high-tech study, and I got a hold of it. And so stop texting. I'm just kidding. I made this up just before I did this video. But anyway, so that's it for that. But let's a few things I want you to remember about R value. Some things these are fun facts with R. Fun facts. R can tell us direction and strength of linear relationships. So, I mean, while you can calculate an R value for something that's curved or not, it actually should be used just for things that are straight, linearity. So always check that scatter plot and make sure, okay? R won't tell you things like form, and won't tell you things like outliers. It doesn't tell you what the scatter plot looks like. So you can't, if you just have someone's like, oh man, look at me, I've got an R value of 0.92. Check out my equation for my model. Well, you don't know if that model is appropriate because it might be curved, and there's probably another model that might be better. We're going to talk about other models that can fit those curved scatter plots, or we can straighten the scatter plots and fit a line to it. R is always between negative 1 and 1. Okay, talked about that. R is the same for x versus y as y and x. So if you switch the axes, the R value stays the same. R is not affected by shifting or scaling the data. Either axis, if you shift or scale, add something to multiply, it doesn't change it because R value is based on z-scores, and z-scores are not affected by shifting or scaling. So you can multiply all the data values by something, add 7 to them all, and they're all going to sell the same z-score. R has no units. Okay. No units, so it's important that you know that. It's made from z-scores. R is somewhat sensitive to outliers, and you could see that, you know, when we go into the effects of wandering points on the R value, you'll see what happens when outliers land in different places. That'll be a couple videos from now. But finally, you can just see this is the formula for R value. It's just the sum of the products of the z-scores for the x and y. So you take the xy data value, change of the z-scores, multiplying, find the sum of all those points and divide by n minus 1, and then you get your outer value. So that's all I have for today. I hope that made some sense. And if you have any questions, email me or leave a comment. I'll get back to you. And good luck with your correlations. See you later.